Welcome to this video on Dijkstra's algorithm. We will demonstrate how to find the shortest path from a starting point, town A, to all other towns in this network. Imagine you are a mail carrier starting at town A. Your goal is to deliver letters to every town by finding the shortest road distance. We follow simple rules. Start at A, track the shortest distances, choose the unsolved town with the smallest distance, and shade it green once solved. Before we begin, we set the initial distance to town A at 0, while all other towns are unknown. The distance label, d of x, represents the shortest path found so far from A to town X. In step 1, we solve town A. We update its neighbors, B and C. Town B now has a tentative distance of 7, and town C has a tentative distance of 9. B is our next target. Step 2, we solve town B. Updating from B, we find new distances for D and E. C already has a shorter path, so we keep that. B is now solved. Next, we solve town C, which has the smallest tentative distance of 9. We check its neighbor F and update its distance to 21. The distance to E remains unchanged. In step 4, we solve town E. We update its neighbors G and H. G now has a tentative distance of 14 and H has 19. C is already solved. Step 5, we solve town G. We check its neighbors D and H. We find a tie for H, as two different paths both result in a distance of 19. For step 6, we solve town D. Checking from D, we see that no distances to its neighbors change, as they already have shorter paths to find. In step 7, we solve town H. Its current shortest distance is 19. We check its neighbors, but find no improvements to the existing paths. Finally, we solve town F. It is our last unsolved town with a distance of 21. All towns in the network are now solved. This table displays the final shortest distances and paths from town A to all other locations. As noted, there is a tie for town H with two equally short paths available.
Now it is your turn. Can you find the shortest paths from E to all other places? Distance to E, of course, is now 0. Update its neighbors, B, C, G, H, to 4, 5, 3, and 8, respectively. Next, focus on G, which has shortest distance of 3. Then, update G's neighbors, D and H, to 9 and 8, respectively. Then, move on to the next step and solve B, and so on. Be patient and finish all. Here is the solution if you have started with E. Among all the shortest paths, the longest path is from E to F via H, which is 15. Note how F is updated via H. Please try another starting point and see what happens. Keep exploring and have fun.